Hello, welcome to the channel. So we have an orange AD200 bass Mark III. This thing is an absolute beast. It weighs nearly 60 pounds and it's a bit of a monster. 200 watts. So let's have a look at the front. We've got power, standby, usual deal, master, volume, treble, middle, bass, gain, passive and active inputs there. This is beautiful, as all orange amps are. Very beautiful covering and beautifully made. Let's have a look at the back. So looking at the back, we've got a slave output, 4 ohms, 8 ohms, the speaker outputs. We've got the fuses and we've also got the failure LEDs on there. And then we've got a couple more fuses here. And we've got an IEC with yet another fuse in there. Let's get this back cover off and we can have a bit of a look at the tubes that are in it. And you can see those are beasts. Those tubes, the JJs. And I have to say, JJs are not my favourite tubes, but everybody has favourite tubes. I still prefer the new old stock tubes. Massive transformer inside there, you can see, and I can see 3 preamp tubes at a glance. In fact, both the transformers are massive, hence why this amp weighs so much. Now, I don't think these are KT88s, which is what this amp came with stock. The customer tells me that these were changed about a year ago. The 6550s, we can see there. Customer doesn't gig this amplifier either, he just uses it at home. So we've got a full set of those in there. So let's power this up. We've got this, just take that out from under there. We've got I'll have to just bring the camera back. That's quite dark now, because what we're going to be looking for is if these LED failure lights come on at all. So we need a power cable. Output valve at failure fuses. Can't see if they're on or not. They are on. Right, so both these fuses are blown, both of them. So that's not good, is it? So are we looking at some kind of bias failure if they're both gone? Let's get it out the case and we can have a proper look. Somebody's been in here. There's no doubt about it. And I will show you. That's all just cold soldered. What on earth did they use on that? How do I know someone's been in it? Because if you look at all the other sockets, there's no flux around any of them. So yes, that's not nice work. And then if we come back here, you can see that capacitor's been changed there, and you can see all the flux around that. looks like a resistor's been tacked on there, I don't know, as well. No, that's right, R17. It looks like that's been lifted though at some point, because if you look at R16, if we go, we just need to pull the camera back maybe just a shade. So if you look at R16 there, you can see that's factory. So somebody's been in here. Oh no, I've just spotted something else. Oh dear. So if we go across here, and if you look in there, we can just get the cables out of the way. I don't know if you can see that, we need the light, but we just move to sideways. Can you see that there? So someone has, it looks like the trace has been damaged on that, so they've just moved it across and tacked it onto that one. Absolute botch. Need to be careful with this amp as well. With those fuses blown, there may well be HT floating around in here if the caps haven't discharged. So the first thing we'll do is check it, because this amp will have some serious voltage on it if it's powering those 6550s. So let's check. You can see it. So we'll just see if we've got any voltage in these on these. Nothing. But anyway, it's always best to check. And it looks like there's been some more work done on it over here. If we look down at those two resistors there, you can see looks like those have been messed with. So somebody's been chasing a fault in here, I think. If we go over here, you can see those two have been lifted there, and you can see that all the flux on those. So someone's been chasing a fault. You see, all this work, to me, it looks like it's all been done top side. In other words, the board's never been out. All the tie wraps are still in place. Here, everything is still neatly wrapped from the factory by the look of it. I don't see any signs that anyone's had this board out at a glance. So how did they get that capacitor out of there? These, because obviously there must have been one of those there, these type of capacitors, they are flat to the board. The only way you can get these out is to take the board out, unless they've got the pliers to it and chopped it up to get it out, which is probably what they've done. But then why have they done that? They're the coupling caps from the phase inverter. That looks like the phase inverter, and they're the coupling caps from the phase inverter to the tubes, I'm guessing. I mean, I'm speculating because I don't have a schematic. So where was the DC leaking onto these tubes, these output tubes on one side. They've soldered around these pins to see if there's a problem, left that mess, and then changed that capacitor. They've obviously chopped that up with the pliers to get that out with the cutters. There's no other way. This board's never been out. I'm convinced this board's never been out. They must be pretty naff capacitors if one of those were leaking, because these type of caps, you never find them leaking. Bit more detective work then. So I've got a test down here, a test label and an inspection and a date of 16th of the, I don't know if that's the 9th on that. I'm looking at it upside down. 08. The board's got a date of 2006 on it, 18th of December 2006. But that says that this amp was assembled and inspected, looks like the 9th, so 16th of September 08. Well, there's some work to sort out in this. This is not just a case of, you know, those fuses have blown and is there a problem? Why? Both sides have blown. obviously one of these fuses is for each side of the transformer, the output transformer. So both of these tubes have got these fuses have gone, not just one of them. So there's going to be some serious voltage on this amplifier. And here we go. And again, I'm looking at it upside down. Warning, voltages of up to 700 volts DC are present in this amp. So we've got to be very, very careful what we're doing in here. Not just getting a nip off it, but also there's a lot of voltage. Right, so the first thing I'm going to do with this amp is I'm going to power it up on with the current limiter and the variac at 110 volts. And the reason that I'm doing that is because there'll only be up to 350 volts in this amp then, and not 700. I'll also have the current limiter on in case we come across any major faults. When we put these fuses back in, we probably will. So if we look there, you can see that meter measures the wall voltage. So I can set that at about 110 volts there. And that's just a bit below half of 240. So that will do us to start off with. The bulbs might take it down a bit more, so we may have to bring it up a bit. So I know I'm having a bit of a moan about this one, but when I open really nice amps like this and see that Mr. Bodge has been in it, it does annoy me. But anyway, let's get on and fix it, shall we? And you can see already, look at it pulling that volt up. Actually, that's just the surge of switching it on from the transformer. That's coming back up. But it has, the bulbs have dropped it. So we'll just bring it up a bit more. We'll go to 120, we'll be fine. There we go, now I know what's going into it. Right, let's just have a bit of a test round and see what we've got on these diodes. So probably nothing if the protection's out. I've got voltage there at 140 volts. So that would be about 280. You've got 144 there. But nothing on those diodes. We need to get a schematic for this really. And we've got another set of diodes here. So we've got 140 of those. 140, 140, 140, yeah, 146. Oh, there we go. 337 there. Coming off those last two. So that's the B plus HT voltage there from the full bridge. And we've got 8 diodes in here. 8 15408s in there. So that's some serious kit. 8 of those. So now if I look at that, we've got 337 volts at 121 volts. So double that. That's a lot of voltage. We don't want a nip of that, thank you. Won't get now. So we've got no HT voltage other than up to a point here, and that obviously will eventually come to these fuses. So let's put a couple of fuses in it and see what happens. And again you can always tell as soon as I saw those fuses on the back, and you look at this where they've just used the wrong screwdriver and damaged them. As soon as you see things like that, you just know when you open it up what it's going to be. They're just giveaways. Right, so I've got those fuses in, but before we proceed with powering this up, I'm going to check the other fuses. And this should be T 500 milliamps, if it's correct. and it is. That's okay. And now there's the mains fuse in this here, which is 3.15 amp at 240 volts, that is. So we need to get that open. Right, so I've checked that fuse, and that's okay as well. So all the fuses are good. Let's just see if there's any bias on there. Yeah, negative 27. So there's bias. Let's just check that they've all got bias on. Yeah, negative 27. Negative 27. So they've all. So we've got bias voltage. Right. So just doing a bit of testing, and we've got 185 volts on there. We've got 324 there. So I'm guessing that'll be the plate, because we should have about the same here. Yeah, 324. So 185, so what have we got on here? 89 volts. So yes, there will be 700 volts nearly on those plates, 600 odd volts. Very quiet, but I kind of hear it through the speaker now. Right, let's just bring the voltage up a little bit. Let's just go up to 150 volts. See what we get. 231. 402. 149 volts in. Yes. There's some voltage there. Right, so we know we've got bias voltage. Tubes don't look like they've had any heat at all, do they? The paint on them looks good. So let's just take off the current limiter. Now the voltage has shot up to about 173 volts. 469 now we've got on those. So let's just ease the variac up. I've just spotted something else in here as well. That cable has been burnt there, so we better just check to see if that's gone right through, because that's the HT fuse. Might be a bit shaky because, as I've said before, I don't do much filming with a handheld camera. So 183, so we're now drawing 400 milliamps. So let's just go up a bit more. So 190 volts now. So if I just put the bulbs back on. Yeah, bulbs just glowing a bit. So let's just check and see if there's any red plating showing. No red plating there. Just go up to 200. So now we're drawing 450 milliamps. Not drawing much, mind it is idling, of course. It'll be drawing some current once the signal starts to go through it, once the guitar gets chugging through it. So we're at 230 volts now. So we're now in the window of what the power would be normally, 550 milliamps. Just go up a bit more. 240 volts, 580 milliamps, and I've got my hand on the switch for the current limiter, so we just need to watch that current and see if it begins to climb. It's not doing at the minute. So the customer's only been using this like in the back bedroom, so he's not had it up loud, so even when he's been using it, the current's not been much higher than that, if higher at all, because he simply won't be able to have it loud enough. And as we know with fixed bias amps, the current increases as you turn the amp up. 20 past 11 at night now, and I thought I'll just open this up. It'll probably be a quick fix. So I can hear the Morgan organ laughing his head off after the comment they left on the Marshall. So yeah, never say it'll be a quick fix. You're doomed as soon as you say that. We have to laugh about it though, don't we? As long as we have a laugh. Well, that's as stable as anything. It's just strange it blew both of the fuses. I've got a schematic here that I've downloaded, printed off. I've also got it on my tablet, which is a bit clearer on there. So we've got the plates coming there. I think that's TX10, TX12 and TX11 goes up there to that 600 volt feed, or 600 whatever, but we'll call it 600 because we can't read it. That is the center tap. So let's have a look on here. TX11 is here, so that will be the center tap. 1 volt, 1.1 volts then on there, on that side. Let's just check this. So 1.1 volt. Right, let's check the next one. 1.12. Next one. 1.23, and the next one 1.23. So the bias is pretty close on all of them. Well, the voltage drop across the center tap and the plate is pretty much the same. We just need to get the plate voltage. 642 volts, and yes, I am wearing a glove. You can see it on camera. 642 volts. So we'll switch off. Right, now we need to check the resistance across each side of the output transformer primary, but before we do that, we're going to check that there's no voltage there, otherwise my meter won't fare very well. Yeah, we're fine. Right, so let's start at 200 ohms on this meter because it's not an auto. So let's just have a look. And we've got 30 ohms. Yep. 30.8. 30.7. 30.8. That's really well matched, that transformer. My word, that's really well matched. Right, the bias comes out at 25.5 watts, and those tubes dissipate 35 watts, so there should be 24.5 at 70%. So it is over. It's only a watt over though, so it's not massive. You know, you wouldn't think that was enough to cause major problems. You know, this amp's not being used on a stage at 3/4 volume or whatever, so I don't know. I mean, we can adjust that as a tweak. Right, so we've got this amp on the scope, and we're going to test it under load now. So if we look, that's what's coming in off the wall, and with 233 volts we're drawing 720 milliamps. So look on the scope here, let's just have a look. Now peak to peak we've got 50 volts. We would expect to see that as well, though. Let's just turn up a bit more. You can hear the fan kicking in now in the hot plate. So we can see that, and it all looks right on there. 830 milliamps we're drawing now on there, 840, and what we need to be watching is that to see if it begins to run away. Do we see any red plating? No. We need to go to 20 volts per division now, because we're going to turn it up a bit more. Sorry about that, just turn the camera a bit sideways. 20 volts per division, and now we're drawing 970 milliamps. Nope, don't see anything red plating. Let's turn up a bit more. Wow, now that really is swaging. To be careful, because I don't think this hot plate will stand 200 watts. The fan is going at it hammer and nail, as you can hear. 1.18 amps now. LEDs are still off, obviously. No red plating there. Well, the customer certainly hasn't pushed it to this level in his back bedroom, has he? So I'm just going to bring that down now, because this hot plate is just beginning to get warm. No, don't see anything wrong at all. Using this in a house, I would have thought you're just going to be flicking the volume up a bit, and so no more than 680 milliamps, 700 milliamps max, I would have thought, because it just simply wouldn't be able to turn it up any more than that in a back bedroom. So that's the gain there I'd got up. And the master volume is full up now. That amp is now flat out. 1.38 amps. It's drawing now off the wall. And you just see it's clipping on the top of the wave there. If we come down, 10 volts per division. Shall we? Let's put it back up to 20. Let's go on to measure. What am I doing there? Pressing the wrong button. Huh. There we go. Let's just, so we've got 66 volts peak to peak. Let's just wind it up. 120 volts peak to peak. Now I've got this on a 16 ohms dummy load, which is at the hot plate, because I've only got the 16 ohms one, and obviously there's only an 8 ohm socket on the back of this, so we're obviously not going to be getting the full 200 watts because of that. That's the first time this hot plate's got considerably warm. It's a beast, but this amp's pushed it. Even the 100 watters, when you put them through, don't particularly warm it up. Gets the fan going. So there we go. So the light's back on now. So that's run absolutely fine, and we've had that flat out. The tubes aren't running away. There's no way the customer's had it up at that volume, and we've had it up flat out, and the tubes haven't run away or anything. So, and those fuses, although they were blown, they weren't black inside. They were just, you know, they'd just blown. So I can't really find anything wrong with this amp. The only thing I can find wrong is the rubbishy work in there, and I'll certainly be putting that right, because as I said, I don't want anyone thinking that I've left that mess. So I'm going to make this a part one. I'm going to go away and just have a chat with the customer. The only thing that does concern me on this amp a little bit with these tubes, so these 6550 JJs, the maximum rated on the plates of these is 600 volts, and this is getting up to around 640, 660. Now I know we push plates, and if these were KT88s we wouldn't even be talking about that. In fact, to be honest, if these were new old stock 6550s we wouldn't be talking about it either. But just a bit dubious about that. But having said that, running absolutely fine. And just a cautious warning, if you've got one of these amps, or you're thinking of buying one or whatever, or you're thinking of working on one of these, you know, normally I always say, you know, look what you're doing, be careful, you'll get a nip off something. You'll get a bit more than a nip off of this. So if, you know, checking the bias on this, when you're using the shunt method that I'm using, you've watched me on here do it numerous times on amps. When you're measuring across the center tap and the plate, we only got 1 volt dropped across there, 1.2 volts. That, be careful that doesn't lull you into a sense that there's no voltage in there, because on either of those wires to ground, there'll be 640, 660 volts on there. That will give you a bit more than a bite. So this, you know, we're up to dangerous levels of voltage, so be careful. Get some insulation gloves, whatever, or just be very careful what you're doing. Never ever put 2 hands into this chassis. This one is dangerous, and you saw that when this is on the scope with the signal generator going through it, 1.38 amps. This is one of those times where I am harping on about safety. You know, most amps will give you a nasty bite, but this one just might give you a bit more, so be careful. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next video. Bye bye for now.